All right, today what we're going to do, I'm probably going to move this fed activity down here, so don't worry about it. We're going to talk about molarity. We're going to do, probably get all the way through the theory, we'll see. If we don't get through it today, we'll finish it next time. I've got it as pre-lab here and lab here. We'll see how we do. I've got everything set up so we can do that today. All right, let's go ahead and go to the notes. So, we're going to calculate molarity. Molarity is moles of solid over liters of solution. If you like the triangle thing, some kids really like the triangle thing, I would write the triangle thing down. If not, you just are doing a simple solution to that equation. We're going to determine the concentration of fluids, which is the most delicious with its molarity. And then we're going to turn in our notes and our assignment for today. Okay, so here we are with molarity again. I like to remember molarity like this. This looks like a mountain to me because we're going to learn things that's really close to molarity. So remember, it's a capital M, and I like to go backpacking and hiking mountains. And there's usually a lake in the center here between the two mountains, right? When you go hiking. So I just remember it is moles of, so the mountain, which is moles, over liters, which is the lakes of the solution. So capital M, moles over liters. Or molarity, 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 moles per liter. However you want to remember it, you got to remember it. Okay? If you're given grams, you have to change it to moles, so we have to use our mole math. Okay? If we are given milliliters, we've got to change it to liters by dividing by 1,000. So we're going to do a lot of practice today. Excuse me. So we can get this down so we're really good. So if you haven't got out your periodic tables, now would be a good time. If you lost your periodic tables, they're over here in a box top right over here. You're welcome to go grab another one. Or if you never had one, you can go grab another one. You'll need it today. We're going to be referring to it. You'll also need a calculator, whether you get one at the back, one at the front, or you have one of your own. Please grab one out. We will be working with lots of calculations today. Is there anyone that needs a periodic table that doesn't have one? Sean, do you have one? Okay. Do you have one or do you need one? You got one? Okay. Please grab a periodic table if you don't have one. Tiger, you have one? Now go grab one. Okay? And grab a calculator while you're up if you don't have one. Because phones just get complicated. It's easier to use a calculator. Okay? I know, I'm making you get all the equipment, materials, blah, 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 blah. All right, now that we got all the stuff that we need, we're going to get started. So make sure your periodic table is open and you can look at it and find stuff fairly easily. Here we go. We're going to be making solutions. We're going to be preparing solutions. In order to prepare a solution, we have to weigh out an amount. We have to put it in a container and fill it up with some liquid. When we do this, we use what's called a volumetric flask. It has one line on it, one line only, and it's significant. So if this is 500 milliliters, it's significant at that line to that many milliliters. So 2 after the decimal. Good. Do you have a calculator? Do you have a periodic table? Yes. Okay, grab those out and grab your notes out.
Solid over the liters of
Solution. Yeah. So what we do is we take this volumetric flask, we weigh out an amount that we've decided, we put it in a volumetric flask, we add distilled water about halfway. There's a reason we do it halfway because we can shake it more vigorously and get it to dissolve in the solution quicker. So once we do that, we swirl, shake it really a lot, and then we fill it to that mark. This is where our meniscus just touches that line. And then we have 2 after the decimal. And we shake it up again. So that's how we prepare it. We're going to be preparing solutions coming up. So we're going to practice it, but not today. We're just going to do the work part of it. Okay? So here's an example. Now we've got to be able to use our equation. I'm going to put it over here. Whoops. It's thinking maybe it doesn't want to write today. Okay. Molarity is equal to moles divided by liters. Okay? So as I look at this example, it says, what is the molarity? So I am looking for capital M when I have this many moles in this much water. Well, that's fairly easy, right? Just plug it into where it goes. So I would put in 3.81 moles divided by 1.56 liters. What do I end up to? Three significant figures. 2.44, good. And we would label it capital M and then NaOH. So I not only tell the concentration, but I tell of what. Okay, so you gotta have both labels on it. All right, you okay so far? We're gonna get a little bit more involved so everybody understands setup. This means yes, this means no, or this means yes, and this means no. Okay, all right. Let's practice another one here. Let's see if you can do it. Oh, well, let's not do it yet because we've changed it up here. Okay, again, molarity is moles divided by liters. Let's see what we've got. What is the molarity of a solution that is mixed with this many grams of this? Doesn't want to write it because I squeeze it. And this much of water. So first of all, I can see that I don't have moles and I don't have liters. So I've got to convert. To get to moles, I'm going to have to get the mass of this. So looking at my periodic table, calcium weighs how much? It's number 20 on your periodic table. 40.078, right? That's what I'm reading off over here. And then we need 2 chlorines. What's chlorine's mass? I think it's 35 something.
35.45.
Thank you. Okay, we're going to add that up. And that's how many grams are in 1 mole of calcium chloride. So how many grams do we get when we add that all up? Well, this will be about 70 right here. If I add 40 to it, I'm going to be above that, right? So 2 times the 35 plus 4978.
0.978.
Okay, so now we can take this 35.6 grams of calcium chloride and use our factor label and say, okay, I want moles, so I'm going to put that on top. I'm using the conversion down here, and I want to get rid of grams, so it goes on the bottom. And grams cancel out. Take 35 divided by 110, and what do we get? Should be about 0.3, I'm guessing. 0. Give me 3 sig figs.
3, 2, 1.
3, 2, 1. I'm counting down. Okay. Mole calcium chloride. So I've got my moles. Next thing I need to do is worry about my milliliters. I've got 550 milliliters. I know that there's 1,000 milliliters, which I want to get rid of, in 1 liter, which I want to go to. Milliliters cancel. 550 divided by 1,000 is 0.550 milliliters. So we take this, divide it by 0.550 whoops, try that again. That's liters. Liters, and I'm going to end up with my molarity. Okay, so I've taken and split it into 2 different parts. I wasn't given moles, but I knew I could change grams into moles. I wasn't given milliliters, but I knew I could change milliliters into liters. Then I set it up like this, right here. And what do I get for my final molarity of calcium chloride? 3 sig figs. 0.584. Okay. Any questions? This would be my final answer. So I guess I'll put a little wiggly around it because it's my final answer. Okay? Got it written down so you can follow it when you have your own problems you got to do? Get it written down.
I'm so confused where we're at right now.
Okay, so let's go back. You're confused. Let's write it down. First thing we did is just identify what we've got. You know where we're at in your notes? That the yellow packet I gave you. Not that one. Maybe get the answers from someone else. Okay, so what I'd like you to do, those of you that are ahead right now, go to the next one. See if you can do the next one all by yourself. You get stuck, bring me in. We'll put it up on the board. Shauna, go ahead and write this down real quick so you got it. Okay. So, do you have a yellow? Then you ask for another one. Don't just sit there. Oh my gosh. Here you go. Now that's my last printed packet, so if somebody else leaves it home, we're in trouble. You can also peek over somebody's shoulder and write down on what it is on it. Look at you go. Woo-hoo. You know, we got that copied down, Shauna, and we can go back one so you get the version. And then I'm going to have you guys come up and present one. I can tell you which one. If you get stuck, let me know, and I will come help you. It's going crazy. This is that's a big one. So you can rearrange the equation. Moles divided by meters. So if you're trying to find moles, you're going to take moles is equal to times liters. I'll let you go back. Right there. This one's a short one, so. Good. Okay, I'll give you a few more minutes and I'm going to give people a number or a one to come up and show. And I'm going to have you take the mic and talk them through it.
Oh no.
Oh, yes. It's not going to be that hard. You can do it. You just have to rearrange them, which is fine. So to get rid of this on the bottom, it times both sides by it, right? So you just, to get moles, you're going to take this times this. Okay. So after the volume in meters, okay, it's not going to be not times it because meters is down here on the bottom. So molarity and meters are going to trade places. So molarity is going to go to the bottom, meters. Okay, on this one, we have to start with the head of the short ones. Moving the molarity to moles, to bottom volume, to not moles by the second times it's meters. So moles. So this one, we have to add an ACL of 1 mass units, and take that divided by the mass to get moles. And then you can use that equation. So here's my original equation, right? And they gave me molarity, and I can get moles out of that, so I need these two. This one. So that one is going to be moles divided by these two choices. Right? Yes. Okay, let's see. So you just took these two times them together. You should know this. So you should, this should be there. And this should just be times your answer. Because you have got molarity and definition, so you've got these two things. You're trying to find out. So you're making an equation to find moles. Moles are going to be molarity times. So times these two. All right, let's see. Moles are, okay, that should work. Just give me the answer. Yes. I don't think so you just take this, divide by that, and your answer for moles. And then you put capitals in it. Okay. All right, I'm going to walk you through a couple. Some of you are still struggling a lot, so rather than having, well, actually, I've got a couple of you that are doing good. Tara, will you come up and do this first one?
Yeah, sure.
And I'm going to give you this so they can hear you talking through it.
1 second. On my hearing.
All right. And the hands are on the side.
There we go. So to get the number of moles, you're going to need hold on, let me read the question first. So to get the number of moles, you're going to need to start with the beginning equation, which is M equals moles over liters. And you're just going to want to plug the information in. And then you're going to need to multiply each side by 0.356. And then what does that multiply to? Forget.
6.37.
Okay, so the answer for moles would be 6.37? Okay.
And don't forget it. Okay, great. Brayden, will you do the next one? Okay, thank you.
Thank you.
If you have questions, ask him, make him explain it.
Do I just select it to get to the next
Yep. Or I can just move it. There we go.
one? Alright.
Yeah, just put it around your neck, it's easier. It's not in your hands.
So we need to find the liters. So the M is 9.909 is equal to, that's grams. So we need to find how many moles that is. 15.2. Find out we're gonna need the sodium. Let's get to 28. And where it is, it's 35.43. And then you just add those up.
Somebody got it for him so he doesn't have to do it.
58.44. So then 1 mole grams equal to 58.44 grams. I don't know what that is, so I'll have to do it.
0.026.
Alright. So
And what is that?
0.026. And this is 0.026 moles. So it's gonna be 0.026 over the liters.
Oh wait, that's the answer.
Oh,
It's 0.267. Sorry.
You try. My arm is getting in the way. You're slight, you're just too.
sorry. What's it?
0.260.
0.260
Moles.
moles. And then it's going to be 0.260 over the liters. So to do this, you have to get the Ly itself. So you multiply both sides by the L. And it's 9.909 times L equals to 0.260. And you divide it by 9.909. And then whatever that is. That is it.
Just put it off to the side.
And then it's 0.6.
And what's units on it? Liters. Awesome. Okay, thank you. Let's see, Lydia, do you have the next one?
I know, but I can try it.
Okay, that's fine. That's great.
So I'm calculating the volumes I'm gonna do.
You have to move it up close to your the mic, or just pull the bottom in, because you got quiet voice.
So we're doing liters again, so we can just do the same thing as here, but so it's 3.909 and then we have to find moles.
You can put it, okay. You just put it on top of it.
And then chlorine is 35. And that's where this box comes to. And then then you add those together.
So if somebody's watching on the video, go ahead and put a plus between those two so they know what you're doing.
So 2 times 35 equals 70.906. Then you just add those together. And that would be 208 .236. So you would put it right here and then so then that would cancel out those.
What goes on top?
And I get 1 mole. Wait.
Yeah.
I can write that. And then you just divide those. And that is 0.313. How many do you want me to do?
So you have 3. I usually take 4 so that when at the end I have 3 that I can go to. Just one more. Okay, so you got a lot of numbers up there.
That's all.
Okay.
And then we're going to use the equation, which is, since we're doing liters, it's L equals mole over molarity. And so the molarity is this, and then we're just going to divide that.
No, other way. Go on top.
And that is how do you get back to this? Oh, I found it. 0.3131 divided by 3.909. Enter. That would be 0.0801.
Okay, and
And
what's
that's
yours?
liters.
Okay. Okay, do we have any that, do we agree with the answer? Those have done it? No? Yes?
I'm done.
Is that the right answer? Oh. So I'm asking.
Sorry, because of the notes.
No, you're good. Okay, awesome. Genesis, would you like to do the next one?
I'm not sure if I did it yet.
Okay, we'll help you through it. Don't be afraid. We'll help you through. Oh, you need to move it on to the next one there. Whoops, too many. Try there.
So we're trying to look for the mass of NaCl,
Mm-hmm.
and we have the liters, so these are milliliters, we have to change them, and we have the molarity, so we're going to change 100 milliliters to liters. And we get 0.01.
Just, yeah, okay. Yeah, yeah. Okay.
And then on both sides to get rid of it and get the M by itself. And I think that's 20.
Don't call it M though. Make sure you're calling it moles. Because M is meters, right? Okay, now it asks for grams though.
Oh, okay.
So now what do? We've got moles. Think about the mole map.
Okay, so we want to convert it to NaCl.
Yep.
Okay, so
Off to the side, you have to add up NaCl. 22.99. I think it's 40, 58, 4.44. Oh, do we want it on the bottom or on the top?
yeah.
What are we trying to get rid of?
So we're trying to get to mass.
So mass has got to go on the. What goes on the bottom?
Moles.
And I can't do that one in my head, sorry. 2 times. Oh, is it 20?
I think it was 0.02, not 20. 'Cause when you multiply 0.200 by 0.1. Oh, you got 0.02.
Oh, well, because it's 0.2 up there. So 0.2 times 0.1 should be 0.02. Moles. And that's because that is a 0.2, right?
Yeah.
Yeah. And then 0.2 times 0.02 times 58.44 would give you 1.67 grams.
Yes.
Yep, so 1.17 grams. Is that what you got? 1.17 grams for the final answer.
I don't know how to find like grams. I don't know how to.
All right, thank
So
you.
I'm stuck on it.
I'm going to walk her through it. Thanks. All right, so what we did here is really quickly, she took the milliliters and changed it to liters, which was 0.1. Then she realized that, okay, this is equal to molarity, and this is moles divided by liters. So she plugged in what she knew. She knew the liters, and she knew the molarity was 0.2. She times both sides by 0.1. She was able to get that many moles of NaCl. Then she had to add up NaCl. So this is Na, what Na is equal to, and this is what chlorine is equal to from the periodic table. Adding it up, 58.44. She wanted to get to, that's how many grams are in 1 mole. She wanted to get rid of moles, so 1 mole went on the bottom, the mass went on top. Taking that and timesing it by 0.02, got this. Okay? Did I lose anybody any place? Okay. All right. Edwin, you ready to try one? Okay, let's try it. Come on up. Next one's yours. If you need help, ask. You can ask me or you can ask anybody in the room. We're going to go step by step. I want to see where you're, how you're thinking through. This is helping me to help you. Okay. talk it through so they know what you're thinking too. I know this is hard. This actually helps you, believe it or not.
So what I did is make this into meters. So I did 750 divided by 1. It's 0.75 meters.
Okay. Now what's that in? Is that molarity, meters, or moles? So right, moles.
And then this.
Okay, make sure if you're following, you're asking if you don't understand where you got stuff. So put the unit on that one too and on the 0.75. Good.
And you times that by 0.75. So when you get
Okay. Make sure you write moles, not meters. I know, I'm going to be stickler.
and then these three will equal 98.072.
Okay, if you're not going to show them, at least tell them how you did it.
So
Say it loud.
I did 2.
1.008.
So that's H, and then that's
32.067.
and then oxygen is 4.2.99. So you times this, times that, and then you add it, and you get that.
Okay,
Wait, what do you get?
so walk her through it again. She hasn't done it before, so really.
Like, no. What's the answer?
So this?
Yeah.
98.07.
Oh, okay.
And then so this times gets rid of that and that. Wait,
The
and
final
times
answer
these
is-
two.
Mhm. Good, yeah. And then good, because that's 2 sig figs. So you only want 3, 147 is what you want to report.
Huh?
So you only want 3 significant figures because the 2.00 only had 3.
So that would be 1 point.
Just 147. I know you've got the pen in your hand, so you got to move it to the other hand there, Chester. And what's units? What are we trying to find? Grams of. Okay, good. Good. Any questions for him before he sits down? Yes?
Where did you get 1.5 moles?
These two. 3 times this, that made that. So 0.2 times 0.75.
Oh.
And then this answer right here came from that. Okay, thank you. Edgar, you up? Ready to try? Huh? No? That's okay. Sean? No? Okay. All right. I will give you a chance another time then. I know you're struggling a little bit. Let's go to the next one. I don't want to put you on the spot too badly, but it really does help you when you try and explain it to somebody else. Okay? So, that's why I forced you to do it, those that got up here. Because they're like, I don't understand where you're getting this, right? And then you have to go back and explain yourself. So that's helpful. All right, so we should have been, those of you that were just sitting here, should have been able to make it through. You have a couple more that you need to do on your own. So hopefully you have enough examples. Oh, okay, never mind. You got it. Okay, I was like, I thought you were on the same page. All right, so what we're going to do is I'm going to explain the Kool-Aid lab that we're going to go do. And then as you finish that, you can finish your work here, okay? So if you grab the Kool-Aid lab out in front of you, we're going to practice making molar solutions, okay? So before anybody gets to start the Kool-Aid lab, and so if we don't get it started today, if we don't get it checked off today, we'll do it next time. But you must have the pre-lab checked off, okay? And we just go through these real quick and then we'll talk about the pre-lab. Everyone gets a cup and a coffee stirrer. Then you put your mark on the cup about 1 centimeter down to make sure you and your partners are about the same distance from the top. You will need to share a scale. Actually, you don't because we're a small group, so you get your own scale. And I've got some instant drinks out there that you can choose what kind you would like to do. You'll need, let's see, there we go. You'll weigh out your instant drink in your cup and then add the water to the line and test all 3 original dilutions. None of those are correct. And then you're going to try and figure out what the concentration is that you should make Kool-Aid with. Okay? And then clean up and put away. So let me go over the actual paper with you. So you have your Kool-Aid in front of you, and I'm going to project it so you can see it too. All right, so what's the perfect Kool-Aid? This is where we're at. Purpose is to correctly find the determination of Kool-Aid that is correct. Okay? We're going to be using an instant drink mix with sugar. Sugar is mostly this as far as the let me see if I can drag this bigger. You guys can barely see. There we go. All right. Sugar is basically C6H12O6. Okay. So we're going to figure out how much sugar we need to add to get certain concentrations. So the first thing we're going to do right here is we're going to take carbon, and we're going to take 6 times 12.011. We're going to take hydrogen, 12 times 1.008. You guys following me, Sean? Braden? Okay. Oh, didn't you get one? Sorry. And then oxygen, we're going to have 6 times 15.999. Would you add that up, check with a neighbor, and see if they got the same answer that you did? Move that up to the top. calculate it through, see if your partner or your person next to you on both sides, if you have two, got the same answer that you did. I don't hear anybody checking. Okay, has everybody got an answer yet? Checked it with a neighbor?
What would the units on that be?
So since we're finding molar mass, we're going to have, hopefully you ended up with this. How do we do? Did I add that up right? Anybody get anything different? We all got the same number there?
181.02.
181. Did you use the same numbers we did?
Yeah. Oh wait, I missed the 1.00. That's why.
Okay, so that's what I got. All right, next step here. We want to find out what mass of Kool-Aid we need to weigh out. Now up here, it said that we're going to assume the volume that we're going to use in the small cups is 0.1 liters. Okay, so we're going to assume that. So we know our equation is molarity equals moles divided by liters, right? And to find a mass, we're going to have to rearrange that so we solve for moles and then change the moles to grams. So to find moles, we're going to take molarity times volume. Okay. A little better. Okay, so we're going to take our molarity, which is 0.1 molar. We're going to times it by our liters, which up here was 0.1 liters for this first one. And we're going to end up with 0.01. And this would be moles of C6H12O6. Everybody okay so far? We're not done though because we can't weigh out moles. We got to change that to grams. So we're going to take and we're going to divide it by 1 mole, C6H12O6, and we're going to put that mass that we found out right here on the top, 180.16 grams C6H12O6. Moles will go out, we'll take and times that, and we should end up with 1.80. Only go to the 10th place because that's all we can weigh out. Okay, and that would be grams of the C6H12O6. Okay, I've done number 1 for you, or B for you. I'd like you to do C and D. Yes?
What did you divide to get 1.0?
So I just took 0.01 times by 180.16, divide by 1. You don't really need to divide by 1. Okay, so quickly follow the same example the way that I did it for B and do C and D.
that. Whoops, wrong way. You can see all the way across. Okay, you should be able to get this coming down. Maybe about another 30 seconds. We're going to go to the next one, and then you can go back, and as you finish it, you finish the pre-lab, you'll be able to go back and finish it, and then get your pre-lab stamp so you can start. Okay, we're going to look down here at these containers. These containers right here, we're going to draw dots representing how much Kool-Aid is in, and we're going to say this is our liter solution. So this whole thing right here would be a 0.1 liter. If each dot represents 0.01, then here I'm going to have a total of 10 drops. Okay. On the next one, how many would I have? Brayden, what do you think? How many would I have on the next one?
40.
40, good. So what about the next one? Anybody have a guess? 70. So we're going to do that. All right, while you're finishing your dots, I'm just going to walk you through again. So you're basically getting to do this all by yourself. You can decide what your perfect solution is. You're going to take and you're going to get one of these cups over there, and you're going to mark it just a little bit, about a centimeter down from the top, all the way around, just so that you fill it to the same place every time. Okay, that's the big thing. Then you're going to measure out the amount of Kool-Aid in another cup that's empty that you figured out on the front. Okay, so for 0.1, I'm going to measure out 1.8 grams in that other cup. Then I'm going to pour it in the cup that I have the line on. So that blank cup is going to be my weigh cup every time. Then I'm going to fill this cup to that line with that nice ice water over there that hopefully still is ice water. Then you're going to use a coffee stirrer, stir it, and you're going to taste it. You're going to observe each thing. So I've got a thing here. How did it look? How did it smell? How did it taste? What was your rating? 10 being the perfect Kool-Aid ever. 0 being the worst ever. Okay? And you're going to go through the ones that we did. Then you're going to say, okay, the best tasting Kool-Aid I think would be between here and here, or between here and here. You decide. Then you're going to try and figure out, where is my list? Oh no, we missed a page. Okay, so after you do that, then what I'd like you to do on the very back page, since we don't have one, on the very back page, make another table like this, and you have 3 new trials. So I missed a page somehow copying it. So you're going to have 3 other trials. You're going to make a table just like this, and you're going to try and find the exact perfect solution. Okay? In order to do that, you're going to have to say that, here's my table. Okay, for my first trial here, I'm going to have to say how many grams I'm going to put in. And instead of going backwards the other way, we're going to have to, once we find the grams, because we'll know it's between this grams and this grams, right? So we're going to weigh out a different amount of grams. We're going to need to find the molarity of that new solution. And then you're going to give me the rating. So it's a little bit different as far as the table, but basically the same. So
I'm not going to have you rate the smell and that. I'm going to have you give me a rating 0 to 10 because now we're coming down on the rip. Maximum you can do is 3 more trials. Okay? Each time you have to tell me how many grams you weighed out and what was the molarity. Now, if I have grams, I'm just going to show you a practice one down here at the bottom. If I have the grams, how do I get back to molarity? Got to put it in moles. So we already know there's 180.16 grams in 1 mole, right? So we're going to be able to find moles. Then what do I do? Once I found moles, how do I get it into molarity? How much volume did we have? Remember from the front? 0.1 liters. So I'm going to take this and divide it by 0.1 liters, and that will give me my molarity. Okay? Everybody okay with that? Sorry, that chart did not get put on. So you can have another possible trial. So this will be trial 4, 5, and 6 to try and find the perfect Kool-Aid. Okay? All right, so once you're done with the front page, let me know. I'll give you a pre-stamp, and then you're able to start. And then you just got a few questions for your post-lab. Yes?
I'm finished.
You're finished. Yay! Okay. Let me